Hello everyone, welcome to the Aero Automation YouTube channel. In this video I'm going to demonstrate how to construct a two-wheel differential drive robot in Webots. This is the dimensions of the robot. The body height is 0.08 meter, radius is 0.045, and remember these dimensions we are going to use it in the construction of a robot. Okay. So first of all, open the Webots, and I'm going to show from the beginning. So go to Wizards, new project directory. So it is showing the location where it is storing the project directory, and I'm going to rename this project by two-wheel drive robot. Okay, click on next, and then don't forget to add a rectangular arena. Add it, finish. Okay, so this is your floor area, that is rectangular area, that is floor size is 1 by 1, that is 1 meter by 1 meter. You can also increase. Okay, so I want 1 by 1, and floor means wall height you can increase, wall thickness you can increase. So all these things you can do it, even appearance also, color also, for color also you can change. So all these things you can explore it. But right now, see, before starting, make sure that the simulation is not running. Okay, and you keep save your work, otherwise it will not be stored. Okay, so that is why that, remember that. And now I'm going to steps how to build a customized robot. So for that, click on the rectangular arena, plus mark, base nodes, robot. Then under that, in the child, you can add plus mark is there. You can add the base nodes again, that is going to transform first. Again in the child, go to the plus mark, that is shapes. In shapes, geometry, cylinder. So already I mentioned the height of the cylinder is 0.08 meters, radius is 0.045. Then click on the appearance, double click on the appearance. In the base nodes, PBR appearance, add. Then colors, red 0, green 0, so that I will have a blue. Then roughness, you add it to 1, make it 1, and metalness, make it 0. Okay, see here the total height is 0.08 meter, but half of the cylinder is under the floor. Half is above, half is under the floor. So go to the under transform node, there is a translation is there. So there in the Y, I need to lift by half, that means 0.04, that is half of the cylinder height. But if I make it, it will exactly sit on the floor. So movement is not possible because it adds the friction, right? So to have that, some small clearance I am going to add, that is 1.5 centimeter, that is 0.0415. Go here, and the clearance here, ground clearance is 0.015, means 1.5 centimeter. I have added extra, so it is lifted up. And this transform double click on the transform, and then in the definition you just add a body. Okay, and come down in the bounding object, double click on it, then you add a body transform, and then physics, add a simple physics. Okay, so this is completed, the body is completed. Then click on the transform node, then plus mark, and before that what you have to do, you have to save it. Okay, line simulation is not running, make sure that. Then go to plus mark on the transform node, then we need to go for hinge joint. That means we are adding wheels to the body. Okay, hinge joint, I'll take it. So there, joint parameters, double click on it, then add joint parameters, then double click on the device. So we are adding motor, rotational motor to that, and immediately motor name we can change it, motor _ 1. This is very important. This will be used in the programming because the motor name we use it as tag names, so that is very important for programming. Once this is done, go to the endpoint, double click on it, then add a node, that is base node is solid, and in the child add a plus mark, the shape, geometry. So wheel is again cylinder. The dimension of the wheel is, height is 0.01, radius is 0.025. It's not visible because it is inside the body, because it is small. Now go to appearance, double click on the appearance, add PBR appearance, then color, I want red in color, so green and blue make it 0. Then roughness you add it by 1, metalness make it 0. Okay, and in the shape you can name it as, okay, first I'll go to the translation because it's not visible. I will make it an X direction, that is I want at the end of the cylinder body. See here, you can see that. Okay. And Y I will lift it to 0.025. Why? Because go to rotation and make it Y0, and Z direction and make it by 90 degree, 1.57. See here, it is rotated. Why I lifted 0.025 means because half of the portion will be below the floor, so that is why I raised by same radius. Okay, so this is a one wheel, so it is saved as a shape. I'm going to save it as wheel. The name of the shape is wheel because so that we can reuse it. Then come down, go to bounding object, use the wheel shape. In the physics you add a simple physics, and you can, in the definition you add the name, that is wheel physics, wheel physics. So this is for wheel 1. And one more important thing is, see, whatever in the translation, whatever values is there, same value should be there in the anchor position also. The anchor 0.045 and 0.025. This is very important step. So that completes the inch point 1. That is, one wheel is completed. So again go to inch point, plus mark. Base node is inch point, or sorry, inch joint. Then go to joint parameters. You add joint parameters. Double click on the device. Rotational motor. Motor name is motor underscore 2. Endpoint. We're going to add a wheel. So in this time you don't have to start from the beginning. Go to use. Sorry, first of all, we should take a basic node, that is solid. In the child, click on plus mark. So don't take shape here. You can take your already saved wheel. You can take that directly. So you can save some steps actually. So wheel is there, but the coordinates we want it exactly opposite, right, to the wheel 1. So go to translation. So x now I will use it as minus 0.045 and y is 0.025 and rotation again in the z axis 1.57. So you can see in this one, see here two wheels are there, wheel 1 and wheel 2. Okay. Now again we'll go to the bounding object. There, double click on it, and then wheel. In physics, you just add the wheel physics. Okay. And after that, what is very important thing is, what is the translation here? Minus 0.045, and this value should be there in the anchor position also. Go to joint parameters in the anchor, minus 0.045 and 0.025. Okay. So the robot is ready now. Now we need to add the controller, and also we should save the work. Now go to wizards and new robot controller. Next. So since we are dealing with C programming language, select C and click on next. Next. The name of the controller is my controller. You can say my controller C. Next. And then make sure that you have enabled this open my controller C.C in text editor. Finish. So here we need to write the code. Okay. So in the first experiment, we are running the robot in forward direction. For forward direction, actually both motors should rotate in the same direction. Right. So for that, we have a manual here. In the first experiment is continuous forward motion. For that, there is a logic here. and this logic. So Control A, delete, Control V. So this is a simple code. That means add the robot library, then motor library, then time step is 64 milliseconds. That means every 64 milliseconds you are going to see the updates. Okay, the maximum speed is 6.20, that is in the Webots value. First of all, I have created the controller and write your code. Okay, and after that you just click on the simulation, means start button, it will not work. Okay, first of all you need to save the program, and then you come to the robot. In robot there is a robot controller. In the robot controller, void is there, that means nothing is there. Double click on it, select my controller C is there, okay, and then save. Okay, and since it is C, you need to build the program here. So first save the program and then build it. In the console you can see what is going on. Compiling is done, linking is done, and then click on reset. Now if you run, see robot is moving forward. So here it is moving continuously forward, but at the end it is going to hit the wall and stops there. Motor is rotating, but further it is not able to move. Stop, go to stop. This is reset simulation. Stop and then go to reset. It will come to original position, that means reference. This is moving forward. So this is the code. That means, see here the process is like define the time step 64 milliseconds and include the robot library, motor library, define the maximum speed, then initialize the robot. Okay, then tag, that means get the motor address, that is motor 1 and motor 2. Then set the motor position to infinity, that means the robot should move continuously forward, right? So infinity means it is continuously moving, the position is continuously changing in the means infinitely it is moving. Okay, so here we are changing the velocity. So velocity is nothing but the left motor maximum speed velocity, right motor maximum speed. This we are going to change the direction. Okay, the concept here is for forward, both left and right motor should rotate in the same direction. For backward, negative, both motors in negative, that is reverse direction. For spinning, one is negative, one is positive. Again, one is positive, another is negative. By changing the speed of motor 1 and motor 2, it will take left hand and right hand, depends upon the value of left or right motor. Okay, so this is a concept. Now I am going to demonstrate here. See, I want to move in backward direction. Now I am going to give minus here and minus here. So in that, go to means click on save, build it again. Now robot should move in backward direction. Reset. Earlier it was moving forward, now it's moving backward. Okay, so like that, if I make it one is positive and another is negative, so now actually it is going to spin in the left direction. Once you make changes in the controller, save it, then rebuild it. Click on run. Before that, reset, then run. So it is spinning in this direction. stop, reset, and this I will make it negative, and this I will make it positive. Right motor positive, left motor is negative. Then save, rebuild it. Run. See, now spinning in other direction. Stop. But now assume that it should move forward and then take a right turn or left turn. So for example, left turn. That means I need to decrease the velocity of left motor and right motor maximum velocity. So decrease means, for example, 0.25, that is 25% of maximum speed I am giving to the left motor. Then save, rebuild, reset, start. So it is turning left. Stop, reset. If I make it for the other wheel, reduce the speed 0.25, 25% into maximum speed, save, rebuild, see, left turn. If you want to have a means, say for example, instead of 25% you can give 50%, 0.5, save, rebuild, it will take a big turn. So this is the concept I'm going to explain here. This one. If left speed is less, then right speed is maximum, then it will take left. Okay, like that it is right also. And speed is same, that means magnitude is same, but negative direction means it is going to spin in the left direction or right direction. That is what I'm going to demonstrate. I have demonstrated recently. And this is the code, and this is what the steps happening here. First, initializing the robot, get the motor tag names, enable velocity, okay, to means position to infinity. Then while loop is there, so that is going to repeatedly execute. See, initialization will be done only once, but while loop keep on executing until you press stop. Okay, set the velocity, and next clean up. So for animation you need to clean up, so that it will going to repeat the simulation. So this is a line by line explanation is there. Means webots.h, that is robot.h, that is robot file, robot library. Okay, and motor library is important because we're using motors. And here time step of 64 milliseconds. Okay, and maximum speed is 6.20, that is a value. And initializing the program, and there is a syntax here. WB device tag. Device tag means motor 1, motor 2, like that, or sensors. So Webots device tag left motor is equal to, this is a syntax, Webots robot, that is WB underscore robot underscore get device. So this is a function we need to remember to get the tag names. Okay, Just get the IDs of the motors and store it in the variable called webots device tag left motor. And now we are setting the position to infinity so that it will continuously move forward or backward. This is set position function, and once it is set motor position to infinity, okay, not stop in any position. The next is motor set velocity, means we are setting the velocity to initialize it to 0 first, and next we'll go to maximum speed. Okay, this main step is control loop. While is a control loop. It's going to repeatedly execute for every 64 milliseconds, and set the velocity to maximum speed. Both right motor and left motor is going to repeat it because while loop is there. And by changing the direction or magnitude of the left motor, right motor, you will get a forward, backward, or spinning left, spinning right, then turning right, turning left. So those conditions you will get it. And at last we need to clean up. There is a function called WP robot cleanup function that is going to clean the current values so that it is going to execute next time. Okay, there is another program that is position control. So here position we set it to infinity, right? So it continuously it is moving. So if you want to control the position, there is a program. So let us execute that also. Position control, that is move forward by 0.2 meters. So I have added a new program. Save, build, reset. That means this will move forward by 0.2 meters and stops. See, it is stopped. It's not infinity. Okay, so this is the code, and target distance here is the variable we have global variable we have designed, that is target distance is 0.2 meters. And wheel radius is considered because to move 0.2 meters exactly, wheel radius is important. Okay, and like that, in the same way, the last program is there, that is to move backward by 0.2 meters. Save, build, one minute. Before reset we should not run, actually that is why it is moved like that. It should move backward. If it happens like this, I will open the Webots again because we interrupted actually. Your program will be there, so recent program always will be there. One minute. save and build it. So we need to wait. Reset and run. What's happening here is there is some maybe there's a syntax issue. Okay, the problem is there's a mismatch with the tag name. See, it's moving in backward direction by 0.2 meters. So I've shown all the outputs, that is around 8 experiments are there. So using this manual, so even I will correct it. So here tag name is wrong. Okay, 8 experiments demonstration is done. If any questions is there, you can put in the comment section or we'll discuss in the classroom. So thank you everyone.